Hello, good afternoon, everyone. This is Royce, the project managers of Singapore Precision Engineering and Technology Associations. In short, it's also known as SPETA, and I will be hosting today's webinars. First of all, I would like to welcome everyone to the Innovating Precision Molding Technology through 3D printing. Today, we are joined by various experts who are very much familiar with the use of additive manufacturing technologies alongside with precision engineering. Before we begin, let me briefly take you through the agenda for today. Okay, we will first begin the session with the opening remarks from SPETA Executive Directors, Mr. Stephen Chaw. We will then take a look at an overview of the additive manufacturing ecosystem in Singapore, which will be presented by NAMIC's Managing Director, Dr. Ho. After that, hearing from them, we will dive into the technical side of things. We will have speakers from Sunningdale Tech Limited and GF Machining Solutions. This will be followed by sharing some of the additive manufacturing training programs available at Nanyang Polytechnic. And lastly, we will finish the sections with some of the information on the grants available to help local companies to kickstart the additive manufacturing journey. And also a half an hour's Q&A section. So if any one of you have any questions throughout the webinars, please feel free to drop your question in the Q&A box at the bottom of your screen. All right, without further ado, let's welcome the first speaker of the day, Mr. Stephen Chaw, the Executive Director of SPETA. And prior to his current role, Stephen actually has spent over 20 years as the Deputy CEO and the Executive Directors at Armstrong Industrial Corporation Limited. With years of experience, I'm sure Mr. Stephen Chaw has many insights to share. Mr. Chaw, please.
Okay, thank you, Royce. Yeah, I'm very encouraged by today's the numbers that registered. I lasted was 181, which is very good. Okay. Anyway, I'm just business strategies. So I will not touch too much on the technology. I will leave the technology to the experts that follow me. But I just want to tell you more from the business sense as the business strategies. So many actually have asked me, hey, why sometimes we call it 3D printing and sometimes we call it additive manufacturing. Actually, that comes from the three types of manufacturing methods. First thing, of course, we talk about the additive manufacturing. That means we add everything in to form a certain components. That's why it calls additive. And then when it turns out it's like 3D dimension, so sometimes we call it 3D printing. Yeah, so it's printed. So now, second one is the subtractive. Subtractive means like you take out from some metal or plastic or whatever. So like, for example, using CNC, you take out some the metal that is not required. So to form a tool, that is to form a parts, that's called subtractive. And then of course, the third one is called formative. Formative and manufacturing. So additive, subtractive, formative. There are three types of manufacturing methods. Now, in Armstrong, my previous company, we do a lot of formative. So we do rubber and foam injection molding. Rubber injection molding, and then we will do foam heat press molding, just to give you an idea. And then from the business points, I think as an additive manufacturing, I will normally look at the material. What kind of material is used? Can I control the kind of material? If the material is being controlled by a few people, then we are in a risk, business risk. So they are basically, as far as I know, there are three types of material: plastic, metal, and ceramic. Yeah, this one I learned from our team leader, Sean Lau. And second thing, you need to take care of the turnaround times to see what is the turnaround time versus your current manufacturing method. Of course, the third is the application. Where can it apply to? Because you cannot use 3D. Sometimes many people say, oh, 3D is very expensive in terms of processing cost and time. I say you have to leave it to see what kind of application you are doing. Like I think high mix, low volume, we can try. Molding to do more, because you don't mass produce more. And then also the prototype, and also quicker turnaround. Let's say in our case, if we need to have this mold come out within a certain hours rather than certain days, number of days, so we can use 3D printing. Another one is sample. I see this the Chang, the curry puff, they produce those parts, those sample for displays. Okay, of course, the last one, the most important is the cost. So 3D, if you look at additive manufacturing versus subtractive, you take out those metal, then you have to sell it as a waste. Whereas 3D printing, no need. It's just like injection molding and a traditional compressed molding. They are good and bad. So you have to start comparing the cost. Yeah. So the last part is I'm very happy that the government is willing to come out and support many SME and particularly precision engineering. They call it open grant. So the last session you will hear what is this open grant. The government will come out and fund you if you are producing certain parts. Okay. That's all for me. Okay, Royce.
Okay. Thank you, Mr. Cole. Okay, next we have Dr. Ho, the Managing Director of NAMIC. NAMIC is a Singapore government platform initiative to catalyze the innovations and skill industrial adoptions of digital additive manufacturing technologies. Since its inception in late 2015, NAMIC has raised millions in public-private funding to catalyze various additive manufacturing initiatives across several industrial sectors. We will now invite Dr. Ho to share an overview of the additive manufacturing ecosystem in Singapore. Dr. Ho, please.
Thank you, Royce. Good afternoon to everyone. Very happy to be here today. Just let me put up my slides first. Okay, so I guess, you know, to start things off, it's important to help you understand the current state of the market and industry. So if you look at the, based on the Wallace report, over the last 10 years or so, the additive manufacturing industry has been growing exponentially. The average compounded annual growth rate is averaging about 24%. Last year, with COVID at its peak, with all the lockdowns in several countries, the industry still managed to grow about 7.5% year on year. Now, the total market size today in the 2020 numbers, it's about 12.8 billion, and that's actually still less than 0.1% of the global manufacturing output, which is estimated about 14.2 trillion. So that gives you an idea that despite the traction and the progress in this industry, there's still a lot of opportunities for you know, for companies to enter and to value capture using this approach. The primary adoption today essentially largely still very much used for prototyping, tooling, jigs and fixtures, but increasingly there are more and more adoption for end part production. So that's something that I think as a whole, whether you're talking about the healthcare sector or in the marine offshore, maritime, aviation, more and more companies are actually looking to this technology to realize actual parts. The growth projections actually pretty much vary depending on which analyst that you're looking at. So Wallace is probably more on the conservative side. They predict sometime in 2025, this industry will grow to about 45 billion. If you look at a more upside estimates, let's say from McKinsey or ARC Investment, they are saying that about 120 billion. And even that is true, 120 billion, that's still less than 1% of global manufacturing output, which is still, which suggests that there is a lot of opportunities for any new entrants to to enter this space. Now, one of the other points that I wanted to talk a little bit about is the fact that this technology, beyond materializing parts on demand to replace spare parts, the real value is in incorporating design from the start. So you have to use the right design approach in order to design specifically for additive manufacturing, as opposed to design for traditional manufacturing. And I'll give some examples in a short while. And I mentioned earlier about the entrance. There's a lot of new companies coming into this space. Have you been following the news? X1, which is a binder jet metal machine maker in the US, was just recently acquired by Desktop Metal. Prior to that, there's been a number of spec mergers, the special purpose vehicle acquisition vehicle that has been created basically to direct list companies. So Desktop Metal is going through that route. Velo3D, another 3D printer maker startup, which supplies machines to SpaceX, Elon Musk's space company, has also been acquired through a spec merger. A few players like you see from the second row from the bottom, companies like Anthropology, which is software, CAD engineering software maker based in New York. They are now in Singapore. Printer Press, also in San Francisco. They are essentially a 3D printing manufacturing service provider specializing in spinal implants. Also has set up a legal entity in Singapore. And the bottom row I did highlight in a red box just to show to you, these are some of the more prominent companies and startups that has come along the way in the last few years. We are in the midst of every 5 years or so, the Singapore government will basically craft out R&D strategy, and this is the Research Innovation Enterprise Plan. So we're currently in the midst of RRE 2025, and manufacturing, trade, and connectivity, that's the national strategic domain. Under this national strategic domain, one of the key focus for Singapore, especially including the public sector research performers, as well as the working together with the economic agency, is to look into how to create sustainable manufacturing. When we talk about sustainable manufacturing, we are in some ways talking about making things in a method and ways that will not overly consume earth resources, which means that we may utilize recycled materials for feedstock and make parts that does not use as much materials, for example, by using lightweighted designs. So these are some of the key future areas that I think it's very important for the precision engineering sector, which a lot of you come from, to be aware of. And beyond the fact that this is of course an additive manufacturing webinar, but I wanted to highlight the fact that this is just one of the key technologies. If you combine other cross-domain technologies such as AI or automation, this combined together will enhance the overall manufacturing hub value proposition. So I have one example that I'll showcase, how we combine these three elements together. The key drivers, of course, for using AM in any sectors, and of course, precision engineering covers. It's a very traditional manufacturing space. It creates products and and components and systems and even machines. Pretty much anything that is in the physical world is created using precision engineering technologies. We understand that a lot of the current players are very, very familiar with the traditional methods, especially the injection molding method, or some of the machining technologies. AM is a complementary technology. So if you're able to use this and adopt this in a way that can support you either in speeding up your product development or help you to create products which can enable more sustainable methods and to minimize waste. So this is one of the key things and key thoughts that I would encourage the audience here to think about when you think about additive manufacturing, is in the way how we can use it for sustainable manufacturing. And of course, you look at all the reasons there. You can accelerate the product life cycle, allow complex design. The economics of 3D printing or additive manufacturing favors high mix, low volume. Okay, so if you're talking about huge volumes, this is not the right method of use. When you're talking about some of these more specialized molds that may potentially improve productivity, where you can insert very more complex conformal cooling channels, this is a very classic example of where 3D printing or additive manufacturing can come in to realize. I mentioned earlier about spare parts on demand. So this is one of the business model that increasingly, especially with the COVID and the Black Swan events, that we're increasingly under pressure on. With what happened last year when economies were locking down, it really gave all of us a lesson that we cannot be too, we have to be more self-sufficient in terms of some of the capabilities, and especially in manufacturing strategic supplies. So additive manufacturing was actually utilized in a lot of ways to support some of the shortages that we were seeing in the medical supply space. For example, like nasopharyngeal swabs, which we actually undertook initiative together with Temasek and EDB. And of course, product life cycles and performance. If you design this well, it potentially can actually help create better functional products with lightweighting, as well as it can also be used for repair. I'm not going to go through all this, but I think given the context that the PE sector plays such an integral role in almost every sector, almost every manufacturing sector in Singapore, healthcare, marine offshore, maritime, to arguably transport, aerospace, of course, complex machinery, which happens to be one of our top performers based on the economic numbers that we had seen last year despite COVID. This is something that we believe will change the trajectory of the competition, especially in the very cost competitive environment we are in for the PE sector within this Southeast Asian market. We believe that by enabling additive manufacturing, a lot of the traditional companies can add an additional element of design and potentially even move up the value chain to pivot to become OEMs. These are some of the key examples of actual situation for every, not all the sectors in specific, but just some of the highlights. You can see what Sembcorp Marine has been doing. They worked with us in the last 5 years. They are already trying to scale up their own in-house capability to provide AM solutions for servicing ships repair. And Ivaldi, ThyssenKrupp, and Wilhelmsen, these are all international companies. And they are in a process of starting a joint venture startup between ThyssenKrupp and Wilhelmsen to produce parts on demand for the maritime space. Even our Port Authority of Singapore has worked with us. So we have created a platform technology. Basically, it combines the few cross-domain technologies I mentioned, AI, automation, and additive manufacturing, to be able to produce these twist lock pins. So twist lock pins are used in the ram spreaders, which is used to hoist containers at the ports. So they use these, they change out these twist lock pins, about 1,000 of them every year. And we're currently basically using this hybrid WAM system to produce these parts on demand. And the aerospace, of course, has been one of the hugely affected industry in the last 1.5 years. The good news is that a lot of the groundwork is being laid as we speak. So ST Engineering, Aerospace, and even Additive Flight Solutions, they're currently all AS 9001 certified, which makes them certified to produce AM parts, right, for the aerospace industry. And of course, semiconductor, which is one of our top performers, again, in the manufacturing world. You have the likes of the filter equipment companies like Integris and Powell Industrial. So they are actually doing 3D printed metal membranes and establishing manufacturing presence in Singapore. So all in all, there's a lot of growth and I would say a lot of traction in the last 5 years in terms of we are building out the whole cell site ecosystem, ranging from machine makers, powder suppliers, software distributors, and also the service bureaus that are dedicated to support manufacturing using 3D printing for the respective industries. And there's a lot of focus on research and development. We are part of that ecosystem. Our differentiation is that we bridge between the public and private in order to focus, and we focus a lot on what's workable for the industry. So if you have any ideas, please feel free to reach out to us. Some of the examples, pump impeller, I think this is a classic example, not from us, but this is just to show you what is doable using, this is using Inconel material built on the SLM 280 system. One of the more difficult parts, you can see the cycle time reduction, where they're able to reduce from 24 weeks to 4 weeks. They are able to also ensure there's no stock out-ish situation. They can build it as they need it. And of course, in most cases, they are also able to improve the quality compared to casting process. Another example of AM is not just the build process, but it also helps to repair. This is an example for Voestalpine. Voestalpine has a presence in Singapore. They, of course, traditionally a materials supplier, but they also have established very good in-house capabilities using direct energy deposition techniques, which is essentially you extrude powders and you apply energy source to melt it. And you are able to do these kind of complex parts, basically putting mill off the damaged portion of the gears and then putting the new materials on top of it. And they are still extremely reliable. I mentioned earlier about the PSA example. So this is a bit more sort of elaborated elaboration of this. It was a multi-year project. We first had to establish what was the business case for us to even develop a large format hybrid system. When I say hybrid system, it actually has both additive and subtractive capabilities. You can see is the concept was we were using a robot arm. Of course, you could arguably do this on a gantry if it makes sense. And we worked with 3D Metal Forge, which is a marine offshore 3D printing service provider, to commercialize the technology at PSA. And PSA worked very closely with us on the process development. And you can see on the picture's probably too small on the screen, but we have now deploying 3D printed twist lock pins in PSA operations. So they're actually running in the field operations as we speak. Some other examples before I want to talk a little bit about our open grant call. Talk about the sustainable manufacturing portion, and these are some of the other examples, just to give you a sense that how the limit is really what you can imagine you can do with this technology. So for a lot of the application that we're looking at is really about utilizing recycled materials. In this case, on the left side, we worked with this urban farm solution provider, Nita Tech. They're based in Lim Chu Kang. They basically used this recycled pallets working with SUTD, and we have this same very large format polymer printer that we could actually produce these 3D printed floating farm modules. So this is actually a very successful project to showcase how, with some imagination and design specific for this, that it can be utilized for the urban agriculture sector. On the right-hand side is another example. I want to highlight this company, Molly Works. So we have plastics This one is actually a recycled metal. Mollyworks actually is a San Francisco-based startup. We actually brought them to Singapore back in 2019. They now have a presence in Singapore. In fact, they are in the process of hiring people to set up the Singapore operations. And essentially what they do is that they have their technology enables them to take recycled metals, scrap metal into powder feedstock for additive manufacturing. And this actually has a huge impact on preserving our environment. For some of you, I think most of us, we don't really know this, but mining industry is actually a very unenvironmental friendly process. So it destroys the environment. With this technology, you could potentially recycle a lot of the scrap metal, especially coming from ships. They are basically no longer needed. Of course, at the end of the day, with all this promise, there are still challenges, and I think I don't want to go very deep into any of this. And we, as the National Accelerator, we are constantly working with our trade association partners, such as SPETA and others, to address some of these. Every sector has very specific issues. So we want to be able to work on some of these problems that the companies like yourself are facing. So do come to us, to discuss, even if you do not know how to get started. And one of the things that we internalized as we were making plans last year during the RA cycle was, and this was a feedback outcome from a feedback that came to us from the industry, is that how do you actually even start? I want to basically apply 3D printing AM for my business. How do I even start? And we internalized that a lot of the companies do not even have the idea of the value chain of how 3D printing process works. So this is what it is, right? So just to give you a very sort of a bare bones thinking, how this whole AM journey can start for you. The first process, in our view, is you need to first identify, if you're a manufacturer or you're an OEM, what are the kind of parts that make sense and can be suitable for 3D printing. Once you decide on that, then you have to take the design and convert it to a format where you can then apply simulations and potentially even redesign, right? To apply either topology optimization, which is a process where you take away unnecessary materials where there's no load bearing, because this will allow you to then fulfill this lightweighting process, right? Less materials, lightweighting, and of course, more environmental friendly. And once you've done that, you do the simulation. Functionally, it seems like the part can perform as what is designed for. Then the next question is, how much does it cost to produce this using 3D printing? Okay, so this is the first step, and this is something that we are planning. We have rolled out this program with Enterprise Singapore. We will perform this work for free. Okay, so we have a few, 3 of our cluster entities, NUS, NTU, SUTD, have this capability for part identification analysis. The second phase, which is the part fabrication assessment, assuming that you have identified the parts, how do you actually, you don't have a machine, so how are you going to realize, right, this parts in 3D printing? So we do have, we have a partnership with the AM Service Bureau, whether it's Forefront AM, 3D Metaforge, even potentially, Creates 3D or some others. So each one of them have different strengths and weaknesses, I would say, but generally all of them will be the partners that we will pair you up with in order to realize the 3D printed product. And at the end of it all, the parts, if necessary, will be tested, whether it's mechanical testing or functional testing, and then even if needed, let's say for maritime, you need to be certified. So this will be done, by the Service Bureau. And this 2-step process, which typically can take anywhere between 2 months to 3 months on each stage, it's going to be supported by a grant that will be given from Enterprise Singapore. So the process that you want to take, if you're interested, is really to kind of reach out to us. There's a couple of names down there at the right bottom. I think this slides, I will make it available. You can have a copy. So Hui Jing is actually our head of programs from NAMIC, And then Wee-Sen is the head of AM within Enterprise Singapore. There is a timeline to this, just to take note. We are currently in August 2021. All the applications should come in by 30th of June 2022. And because of the COVID situation, just to let you know, there's an enhanced support level of up to 80% that will be applicable for any submissions between from now to 31st March 2022. And each project cost will be capped at 40,000 per project. This is actually a lot of money. I would encourage you to utilize this opportunity. Again, like I said, if you don't have a clue how to get started, I suggest just contact us, and then we will discuss with you how to go about doing this. And with that, I'll end my presentation. I'll hand it over back to Roy.
Thank you, Dr. Ho, for the sharing. Next, let's dive deeper into how you can streamline and optimize your metal additive workflow with Mr. Adrien, who is the Business Development Manager of Advanced Manufacturing at GF Machining Solutions. Adrien handles GF Advanced Manufacturing's portfolio, which includes their innovative products such as laser texturing, laser micromachining, and additive manufacturing. His expertise in advanced manufacturing technologies enables him to offer end-to-end solutions to meet the GF's customers' challenges when it comes to industrializations of innovative products and innovative ways to manufacture. All right, let's hear what Adrien has to share with us. Adrien?
Yes, hello. Thanks for to give me the opportunity to be with you. It's a great pleasure for me. I'm very happy to present what GF could really bring you into the market. So before starting, I just would like to maybe to present myself, despite you present me quite well already. So I'm from Switzerland because I used to work for GF for the past 10 years. I started in China, in South China exactly, for the last 6 years, where I was in charge of the business development of our most innovative product line at that time, which was laser texturing. Then I moved back to our headquarters from 2015 up to 2020 to take care about the product management of laser texturing, and I start also, with the integration of additive manufacturing product line with a first partnership with EOS at that time. And since January 2020, I moved back to Asia to support our company to improve, I would say, our footprint in Asia Pacific. I start to take care about the marketing department, and since July 2021, I moved back to the business development department, yes, to take care about the most innovative technology that we have in our portfolio, which is texturing, micromachining, and obviously the 3D printing, or so-called additive manufacturing. So today I'm very happy to be with all of you, because it's something that is very interesting to me. I'm very happy always to talk about innovation, and innovative technology is really something which really passionate me. And before starting with my presentation, I just would like to remind you who is Georg Fischer. Georg Fischer is a Swiss company headquartered in Schaffhausen. It has been created in 1802, so yeah, 2 centuries ago, more than that. We are present in over 34 countries over the world, about 14,000 employees worldwide. And as you can see, we have 3 divisions. The first one, which is piping system, which is a leading supplier for pipe for the transport of liquids or gas. The second division, which GF holds, is GF Casting Solution. In the past, it was more known as GF Automotive, and is a division which is in charge of the development and the manufacturing of casting and also additive components for customers in various industries worldwide. They are leading provider of lightweight components in the mobility or even energy industries. Both piping and casting solutions are not stranger about additive manufacturing because they are using this technology for many applications such as molding or the production of aerospace or automotive parts, to name a few. Oh, sorry. The last division where the webinar will focus on, where we come from, is a GF machining solution, and we are a leading provider of machines or automation solution and services to the tool and the mold making industry, and also to the manufacturer of precision components. To talk about product or technology that we have into our portfolio, you can see that we have different high technology machines like EDM, for example, die sinking machine or wire cutting machine. If you know some brands that we own, like Agi Shami, I think this you will recognize. We also have our milling technology, 3-axis, 5-axis, high-speed milling. So this is a former brand which is so-called Micron, also from Switzerland. We have also the spindles like the brand StepTech. So we are also providing, very high-end spindles to the other manufacturer as soon as they are talking about high efficiency, high performance of spindle. So they are using our spindle solution. You can see also that we are able to provide tooling and automation system in order to automate, the different technology and really to improve the flow of information between the different technology that I mentioned before. And last and not least, digital transformation. Everybody's talking about Industry 4.0. This is our new baby, and we are also developing quite a lot of features about that. So in order to bring to customer, and especially for, I would say, to major OEMs or manufacturer, to bring them a clear KPI about their workshop or their production. So as a business development manager for advanced manufacturing, I take care about texturing, additive manufacturing, and micro machining. So this is the area of, I would say, my center of expertise. So in this webinar, I would like today to show you how additive manufacturing could move from a technology of prototyping to a more, I would say, integrated manufacturing process or technology. Today, we'll talk about one example. It's not an example about mold and die. It's an example about a motorsport industry. This is a double charger for a motorsport, like, for example, you can talk about Formula 1. Is not exactly the real part, but it's a good example about how our integrated workflow can be applied to have, I would say, good parts under tolerance without any deviation into the process. So the production of such integrated manufacturing solution based on 3D printing technology required a lot of understanding, a deep understanding of the upstream elements like the design, the preparation software, the printing technology, but also the material, the parameter development, as well as the downstream elements, including the post-processing, like the EDM, such as wire cutting or die sinking, also milling. And we can also think, if we think a little bit further, to add also texturing technology onto the surface of the parts. So we need to bring to the market, I would say, a full integrated workflow where customer can really master the entire process from the design up to the final parts. So as a result, the capacity to offer such end-to-end workflow is highly uncommon. So this is quite unique. And this is exactly what the strategic partnership between GF Machining Solution and our partners 3D system is all about. In an industry where all are learning and are busy developing application capability, the power to offer an integrated metal additive workflow from a single provider, which is also an advanced additive user, is unique, and you can help to shorten our customer adoption curve. So if we can take the view of the part that we have seen just before, you can see the different steps that we did, like the design, the preparation, thanks to our software 3D experts, up to the building process, thanks to our additive machine, which is a DMP Flex 350. We also have the biggest machine into the market with the 500. We are able also to inspect I would say the good execution of the process in advance. We are able also to simulate and to generate the CNC program for any milling machine, not only our GF machine, but also other brands. And we are able, of course, to I would say to also to execute post-processing into a single solution provider. So if you look more into the detail about the different steps that we did for this part, and again, you can imagine, you know, the same process which can be applied to a mold insert. There is no any difference on that. So with our software, you're able to design a part. So this is the part that I showed before. This was the first design, where we also include an element into this design, which was a gas valve, waste gate valve, sorry, which is just here. You can imagine how difficult it can be, you know, to cast in one piece this part, or also to weld these parts, because, you know, the thickness of the wall is very thin. We are talking about less than 2 millimeter wall here. So, you know, the complexity of such the kind of design can be mastered with the AM technology. At the end, the part that we'll talk about looks like that. So we have the double, we have the valve, but also we integrate a double wall into the part in order to reduce the weight of these parts without any consequence into the performance and also into the manufacturing process. So this was the first step that we did with our 3D experts. And as we say, you know, as soon as you prepare a design, you need to make sure that the execution will be well done. And thanks to our integrated workflow and also our 3D expert before machining, we are able to program and to prepare the program in order to make sure that the production will be done without any difficulty, both in printing, but also into the post-processing process. So the software will advise us, here you can see in this picture, on the support generation needed for the building process, as well as the part orientation in order to optimize the building process or the building efficiency of your parts. Into 3D expert, you are also able to simulate the process in order to make sure that there will be no any deformation or stress into your parts. This is very important also into the printing process. And the last step that we are able to perform is to slice and to process, to monitor the full process in order to guarantee the well execution of the building process. For one final goal is to make sure that your part will be printed properly. This is something that we always want to do at the GF machining solution. We are always thinking at the customer side. We know quite well our customer environments. And as soon as you have one partner able really to guarantee the full workflow, even into this stage, this is what we call, you know, to be really customer centric. And this is what we are here about. But before to build the part, so we were talking about the preparation, the design, the preparation. Of course, we need also to prepare the machining. And we all know, sorry, that after 3D printing, I would say, yeah, 99% of the time, you will need a 3D post-processing. And I would say the referencing of your parts is always a challenge for all our customers. As soon as you come from the 3D printing up to the milling technology, you need to make sure that the position of your part is well done. And this is why into our AM machine, we include, the very famous System 3R tooling. I know in this webinar, most of you into the modern die industry, quite well the System 3R tooling. With that, we're able really to make sure that the reference of your parts from the building process up to the separation process of your part which has been printed up to the milling or to the separation, you will have always one reference. You don't need to do, I would say, useless setup into the different step of your process, which means you will optimize, your process. You will optimize the efficiency of your process. But the most important also is you will make sure that no mistake will happen, into the setup of your parts. Because as soon as you set up a part manually into the different step of your process, obviously, as soon as you are talking to any operator, the risk of mistake is always here. We are all human. So this is really I would say the key advantage of the System 3R tooling, which is already implemented into the building process with our DMP machine. So the DMP machine, the printing step has been done with our DMP Flex 350. And it's really allow exactly, what we mentioned before, to have a perfect printing process without any quality deviation. This can be mastered thanks to our vacuum chamber. This is providing a consistent low oxygen environment up to 5 ppm during the process, resulting on minimum powder oxidation. So minimum powder oxidation, obviously, this means higher quality of printing, especially when it comes to creative materials such as titanium, or aluminum, and the like. But also, if we talk about modern die, we have also some powder which is similar to Stavax. This is also can be applied. The removal print module for holding both the fresh and the used powder, as well as the print parts, which can be welded outside the printer and replaced with another such RPM, carrying same or different powder in order to minimize the machine downtime itself. So here you have really, I would say, a machine which is ready for high production printing job for additive manufacturing. As we mentioned just before, obviously, this machine is equipped to the System 3R clamping solution that you have seen before, which will be the key points, to do the link with the next step of manufacturing of these parts, which will be the post-processing. So this is a part right after printing, and in order to make sure that the position accuracy of these 4 areas that you can see here, the 4 holes, the milling process will be needed. So after printing that, you can see that this part is mounted into the System 3R tooling, just below the parts. So we prepare the NC program and we move to the milling process. And the milling process will be done with a 5-axis milling machine. And here the goal will be to machine these 3 areas, the 6 holes, which will bring, the position accuracy that the motorsport industry require, but also the surface and the concentricity of the hole. I would say the bigger cycles here. This is the same challenge of the last 2 small areas that you see on the left-hand side. So this was done using our Mill E700U, which is a 5-axis machine, high efficiency machines. Why we're using 5-axis machines, and this is, I would say, the similar advantage that we can apply to a mold insert. The goal here is always to reduce the number of setup. So here, using a 5-axis milling machine, we're able to do the different face of the part in a single setup, which will optimize again the productivity of our customer, but also which will reduce the setup time, the setup that you need, which will also reduce the number of clamping, or I would say a different setup that you will need to do on your parts. So this was the milling. We will need also to do the other part of the side, but I will not go through. It's exactly the same process. But after, we need obviously to separate, you know, the parts to the building, to the systems we are tooling. And this one we will use a dedicated wire cut machine, fast wire technology machine, which is a CutAM 500, which is here really to optimize, you know, your separation process from the build plates. It's as I say, it's a fast wire technology with a double spoon. Also, it's allowed to rotate, you know, the table in order to improve and to make sure that your parts will not be damaged after the separation of the parts. So here it's a view of inside the machine. Here you can see the double spoon. And this CutAM is equipped with our intelligent power generator. In short, we call it as IPG generator, which is a state-of-the-art digital generator. And what we can see with our different feedback from the field, because we have quite a few machines on the field already. Having such kind of technology into the markets, we are making sure that your part will be always separate without any damage. We are experiencing no wire breakage during the process, even if you have remaining powder into your part, or also if you have very complex profile. This is something that the AM industry was looking for since many years, and this is a solution that GF bring into the market 2 years ago. So this was a story about these parts. You can see on the left hand side, so the first printing process of the parts up to the milling process, and at the end the part which was done after printing, after milling, after separate. So this was a story that we can apply into the mold and die. Obviously, I use this part because it's very challenging in terms of complexity. It's very challenging also, you know, for the milling technology and for the separation of the parts. So obviously, for molding, so this I would say this concept of workflow can be applied, and this is we know at GF this is what the manufacturing sector was looking for, to move the AM technology from prototyping to manufacturing. I would like to show you one example of mold and die. This is an example of customer base in China, South China. This is a superstructure for fixing a smartwatch into its packaging. So you can, and here this part is, I mean, the application is also an hybrid application. You can notice here on the right hand side where we print the part with our DMP machines. And you can also notice on the left-hand side the conformal cooling channel that we add into the mold inserts in order to improve the injection, the cycle time of these parts. You can see on the below corner left, you know, the different simulation in terms of cooling. You can see with a traditional cooling system, you can see that the cooling is not very homogeneous. And with the conformal cooling, we really optimize the I would say the conformity. I mean the homogeneity of the cooling of the plastic parts. In this case, customer enjoy about 20% of reduction of injection time. So this was quite impressive for them. Obviously, when we are printing a mold insert, you know, the benefit is really at the injection aspects. So 20% of reduction into the cycle time is very something that was appreciated by the customer. So this was an application about mold and die, and we receive also some requests about right after printing, right after separate, or what after milling the shape or the surface, or also the accuracy of our parts, bringing a touch of additional innovation through our very innovative technology, which is laser texturing. With this technology, customer also can bring, I would say another aspect of innovation. As soon as you're improving your manufacturing process through additive manufacturing, if you go a step further with texturing, you can really improve either the aesthetical aspect of your parts through different grain, which is replacing chemical etching, for example, or to add also a functional surface. We are working with OEM to develop some functional surface. And in this case, we can think about how can we improve the demolding, or I would say to reduce the sticking effects from the plastic into the insert of the mold. So this was the story that I wanted to talk about. I would like to thank you again for your attention. You have my contact here. Yeah, so that was my presentation. Thank you so lot for your attention, and please stay safe during this time. Thank you.
Thanks, Adrien, for the sharing. Really insightful. Next, we have Mr. Chaw, the manager of the Additive Manufacturing Innovation Centers at Nanyang Polytechnic. Mr. Chaw has more than 20 years of practical experience in various additive manufacturing industry projects across various areas, which include precision engineering applications. He is also the course manager of NYP's specialist diplomas in precision engineering, in which more than 500 professionals were trained on additive manufacturing in the last 5 years. With this long-standing experience with additive manufacturing, Mr. Chaw will be sharing on driving capabilities development through collaborations and trainings. Mr. Chaw, please.
Hey, good afternoon, everyone. Yeah, I would like to share about how we drive capability developments together with industry to collaboration and also trainings, right? So actually for Nanyang Poly, we have long history of partnership with precision engineering since our School of Engineering, German Singapore Institute, GSI time more than 30 years ago, right? So we have been supporting and supplying precision engineers, manpower development trainings, and also capability development, right? So our the partnership triangle includes learners, staff, and industry, where we have learner scholarships and also structured industry attachments to industries. And we have staff development through our collaboration projects and also applied R&D. And for industry, we have been providing relevant trainings and customized courses, and also OJT at the industry place or at Nanyang Polytechnic, and throughout our workplace learning systems. So how we partner is by stages, from various stages, from stage need analysis, customization of the training for the specific industry needs, and also hands-on practical skills training, from basic, advanced, intermediate to advanced, right, including future-ready on-job trainings, and also providing solutions with co-creating together for new breakthroughs with our NYP's innovation centers and via companies and collaboration projects. Right. So our Center of Digital Engineering has been established earlier, and it has a wide range of precision engineering setups and groups, including additive manufacturing. Right. Then later on, around 2014, by the support of EDB, we have established Nanyang Poly's Additive Manufacturing Innovation Center, and we have been providing AM solutions and also providing manpower training with short courses, work skill program, and also studied specialist diploma in precision engineering on additive manufacturing and skill future series programs. So we have been using our training facilities on both metal AM systems and plastic AM systems with a wide range of material industrially applicable to precision engineering and also other sectors, right? So these are more popular or widely used industrialized systems that can be directly applied to the need of our local industry. So our industry verticals includes PE as well as aerospace, marine, offshore, and medical healthcare, right? So we have a wide range of applications and also a lot of projects over the years, then together as a testbed for industry, providing a solution or joint collaborations. Right. So as an example, we have a collaboration with Sunningdale Tech and also a NAMIC grant project, thanks to Sunningdale, Simon, and also NAMIC as well, right? So we have generated a software or analysis software for quick simulation and also generation, automatic generation of cooling channels, right? And that is developed and it's already deployed, right? So the next project is also the tooling for an example of conformal cooling for light guide of side mirror of a car, right? And with this project, we managed to maintain the geometry and accuracy of the injection molded part, which is very thin and also transparent. So we have provided specialized cooling via simulations and also optimization of parameters. Right? Right. So we have developed together with Tech, so they managed to secure the job order from the main con or OEMs for this tooling projects. Right? So the next one is also a NAMIC grant, which is recently completed as a breakthrough to obtain YASA certification, supplemental certificate together with SD Engineering Aerospace. So we have jointly developed a solution to go through the certification, EM qualification, and certification processes. And we have come up with the optimization for this type of cabin components for aircraft use. Right? So it was lightweighted and topology optimized, and it is for certified to use in the aircraft. Then our process of direct metal laser sintering EOS 290 was certified or qualified for printing aerospace parts. Right? So we have further developed together with SD Engineering Aerospace for some of the aerospace components as well. So in addition, we also have demonstrated for marine qualification and certification of 3D printed or additive manufacture parts or for quality control and quality processes for the kind of from quality records to process control for marine applications, right? From the certifying body, American Bureau of Shipping, and with the partner shipparts.com, who is a kind of distributor for various marine components. So this is also an dynamic grant as well. So in terms of the trainings, right? So we have various areas of industry trainings. from basic, intermediate to advanced level, right? And a lot of short courses and a series or suite of 3D printing or additive manufacturing short courses, right? From 1 day to 2 to 5 days, right? So, and if there are more deeper skill and training needs, we also provide specialist diplomas and different programs, WSQ, SGUS, and also what scale program, WSPs, right, with different qualifications and also different durations. Right. So for example, we have specialist diploma and a WSQ with SSG grants for precision engineering diploma, master craftsman skills, and also specialist diploma in precision engineering, master craftsman, as well as specialist diploma for additive manufacturing part-time courses. Right. So we have been running 2 intakes per year due to the high demand since 2015. So it's already more than 11 intakes conducted. So for daytime, we have different programs for SGUS. For unemployed Singaporean, we have government support of 1,200 per month for the participants. And these SGUS programs, including additive manufacturing. For it, we have 2 days per week for 10 months. Then for work study programs called WSP, earlier called and learn program, for jointly trained industry employees with the Nanyang Poly and also with the company with on-job training at the company. Right. So we also have different areas of specialist diplomas, right, including additive manufacturing. Right. So for this program, work study program, we are targeting fresh poly or ITE graduates, graduated less than 3 years, right, and employed by the company and put on the on-job training and these programs. So the intensives can be up to 15,000 for the company, and for participant is up to 5,000, right, for under these programs. So our AM offerings or additive manufacturing trainings, as explained, we have various formal courses to short courses for different levels and different type of knowledge and skills, right? So yeah, over the years, we have trained for more than 100 companies, over 500 participants, mostly PMETs from precision engineering sectors as well. Right? So for specialist diploma, it is a part-time WSQ with structure from basic, intermediate, advanced to specialist level with pairs of modules from basic pairs from design and process, advanced design and process, and also specialized projects, right? And the structure is 2 evenings per week for 10 months. So most of the modules, more than 70 to 80%, are hands-on lab-based modules. Right? So yeah, the participants need to come to our labs and do their studies and practicals. Right? So for industries from various industry has been taken up, and we have batches of completions under these programs. So for short courses, we have a new short course coming up, collaboration with Materialize Belgium. So we have a 2-day short course in September, where we have overseas trainer from Materialize conducting online training, and also 1 day on site in NYB for demonstrations and also industry project explorations. Right. So this is under Scale Future grant as well for various options, right, for citizens and for companies, right. So in general, the cost subsidies varies from Scale Future from 70% to 90% for about 40 years. And we also have National Civil Academy courses by this NSC at 50% subsidies, specialist diploma SSG grants, and also HUS grants as well. Right. So the key takeaway for the sharing is that we have different options of development collaboration, and as a kind of from machine consignments to developing some research and grants, joint grants seeking, and also test bed for additive manufacturing solutions, where we help industry to carry out the projects together to come up with variable solutions and breakthroughs. Right. Then we also have internship attachment of our learners to industries if you need those type of attachment, and also for manpower trainings for industry employees and to reprofile or retrain on AM. We have various levels from day short courses and part-time short courses. And also we have customized trainings we have carried out over the years. Right. So the next upcoming specialist date in November, and also short courses in September. Yeah, these are the contexts if you have any inquiries. Yeah. Thank you for your attention.
Thank you, Mr. Chaw. Great to know there are these additive manufacturing training opportunities available. Okay, last but not least, we have Ms. Tan Hui Chi, the head of program at NAMIC. Hui Chi oversees the entire NAMIC project portfolios and partners with pillars heads on funneling industry and upstream research projects. In June this year, Enterprise Singapore and NAMIC have launched an open grant call for part analysis and design for additive manufacturing program to help local businesses start their digital transformation journey with additive manufacturing. So she will be sharing with us more detail on this program. Hui Chi, please.
Thanks, Royce. Good afternoon, everyone. In view of the tight timing, I will quickly share about the grant call application that application process that we have launched with Enterprise Singapore recently. So I will skip this slide where earlier on Chow Sing has already shared about the details of the grant call, which consists of phase 1, the part identification analysis with the NAMIC tech hubs, which are the 3 universities, and also phase 2, part fabrication and assessment with the AM Service Bureau. So I will jump straight to the application process. So this is the application process flow that all the companies who are interested to apply should take note of. In this grant call, as this is separate into 2 phases, the proposal that we are receiving will also need to cover the scope that the company would like to do in both phases. So the company would only need to submit one-time proposal, which consists of the list of parts that they have identified and they would like to study and print in this entire program. So the proposal should be crafted together with the AM service provider at the beginning, and it should include the problem statement and part details, and also the clear deliverables and timeline for the 2 phases. So the Service Bureau should also provide the indicative project cost to the company, which include the fabrication, testing, training, consultancy cost items. This proposal will be sent to review by our panels, and once it's approved, we will issue the letter of award to the company and also the university there will be an agreement between the university and the company. And then we can start the phase 1 part feasibility assessment process. So this phase, as mentioned earlier by Chaw, is free of charge. The NAMIC Tech Hub will help to do all the analysis and simulation and also cost analysis for the parts that the company has selected. And then at the end of phase 1, there will be a review together with the service bureau and the company to go through the suggestion given by the IHL Tech Hub. So from the review, there will be a few parts that the company will shortlist and then put it through phase 2 for the actual fabrication assessment. So prior to the start of phase 2, the company will need to submit the required document, which is the summary report of phase 1 and also return support by NAMIC, and the final quotation that is aligned in the end of phase 1 review. Upon approval from ESG, they will issue the letter of offer to the SME company, and then this SME company can work directly with the service provider to kickstart the fabrication process for phase 2. So as mentioned by Chaw earlier, this is a highly incentivized process. So I will talk about the grant quantum later. Yeah. So at end of phase 2, there will be a final review conducted by the company, and then ESG or NAMIC and NAMIC will be present at the final review to review the outcome of this entire program. So if let's say the company is satisfied with the AM printing outcome and they would like to proceed further, there will also be other support that ESG and NAMIC can potentially support and provide for the company to do further evaluation on the parts that they would like to print or in their future production. So this is an overview on the scope, the project team, and also deliverables that is expected from the grant call. I will just quickly talk about what are the scope in phase 1 and phase 2. In phase 1, it will cover the part analysis and optimization, plus the cost and lead time simulation. So at the end of phase 1, the NAMIC Tech Hub will provide a feasibility assessment report for the parts that are selected by the company. And based on this report, we will choose the part that the company agreed to print together with the service bureau, and we proceed to phase 2. Phase 2 will be the actual printing and testing and qualification. So in phase 2, the outcome that we are expecting is the actual printed prototypes and also the evaluation of these parts. We will be looking at the final printing strategy, the qualification outcome, and the company will also need to provide the estimated productivity and lead time improvement. There will be gap analysis discussion together with the service bureau. And if the company decided to proceed, we will also get the company to share their workforce development plan and their future 3D printing adoption plan. The next thing that I would like to share is the application details. So for eligibility wise, the company who apply for this grant should be a local company that falls under the EDG criteria. They have to have legal entity and presence in Singapore with more than 30% local shareholding. All the work should be conducted in Singapore. Funding support wise, for phase 1, it will be free of charge. Company only need to provide matching in-kind co-funding, for example, like manpower. And in phase 2, it's supported by the EDG scheme through ESG. So the company can put up a project with maximum 40K project cost, and EDG will defray up to 80% of this project cost. Which means if you're putting in a project that costs 40K, the maximum support that you can get is about 32K. So this is a highly incentivized project, which we really encourage the local company to leverage on. Yeah. So this 80% support level will last until 31st March next year. After 31st March, it will fall back to the typical 70% level support by EDG grant. Yeah. And the application timeline wise is already open now. It will close on 30th June next year. So we encourage the company to submit as soon as possible, especially before 31st March, to be qualified for the 80% incentive. So the proposal template will be available in NAMIC website. We'll also sign out later after the webinar ends. Contact information, if you have any question, you can email me directly or my counterpart in ESG Reason. So with this, I would like to end the sharing of this application detail and hand back over to Royce. Thanks.
Thanks, Mitzi.
Thank you.
To round off the webinars, we will be proceeding into the Q&A sections. So can I invite all speakers to turn on your cameras? Okay, for all attendees, you may continue to leave your questions in the Q&A box, and we will try our best to answer as many of them as possible. And now I will hand over to Mr. Hlwan, the General Manager of Create 3D, to moderate these sessions. Hlwan has accumulated technical experience with a variety of different 3D printing machines, technologies, and applications across all industry sectors, which help him to gain foresight into the macroeconomy of additive manufacturing's potentials. With his active involvement in the local additive manufacturing committee, I'm sure Hlwan is more than excited to facilitate this session. Hi, Hlwan, over to you.
Thanks, Royce. So besides being the general manager of Create 3D, I also support and help SPETA lead the AM education or promotion of additive manufacturing for the SPETA members. Okay, so let us start with the questions that several audience has placed, and thanks everybody. Thank you all the speakers as well. So the first question probably for Simon is, how much finished machining stock is kept on the 3D printed inserts?
Generally, we leave about 0.3 to 0.4 stock for machining. And sometimes also depends, if you expect to have a little bit of warpage, then you probably would have to add a little bit more.
Okay.
But so far in general, it's about 0.3 to 0.4 stocks. Yeah.
Okay. For the other speakers, if you have other comments, feel free to add as well. Another one that is coming in is for the lattice prints that you have mentioned in the earlier slides. Do you use them purely for support structures, or do you use them within the inserts as well?
No, not only support structure, lattice structure. It can be used for weight reduction. It can also, it's actually that this structure is there's a lot of application. In fact, that this structure is a wonderful structure that the AM should exploit as much as possible. So even for us, we are learning this how to use lattice structure as much as we can, as often as we can, without compromising on the quality of the part. So it's something that we are still, to be honest, we are still learning. We have a few applications that work out to be quite successful, but still we are exploiting as much as we, because in lattice structure there are a lot of design. Software will provide you with many types on, so there's so many there. So actually there's quite a bit for us to go and explore what are the useful one as well. Yeah.
Okay. The next questions could be for both Simon and Adrien. As we know, metal AM requires post-processing, right? So maybe for Simon, you can advise, let us know about how you overcome the challenges facing related to QC output, accuracy control, etc. And maybe Adrien can also comment, because I noticed that in your slides you mentioned about linking the whole chain up as well from your solutions.
Okay, so far now, as far as the post-processing after AM, we typically do heat treatment, and we heat treat it from the the hardness that you, when the hardness that you get out of just AM is not hard enough for our mold making inserts. So what we have to do is that we have to go through heat treatment. We raise the temperature, we raise the hardness up to about 55, 57 HRC, and then thereafter then we machine it to size. That's where the accuracy of the inserts will then be formed. Then the cost post, there are a few other things is that one of the things is that the cooling channel. How do you deal with the cooling channel? One of the things that we do is also we do we do electroless nickel plating into the cooling channel, which is one of our standards here. Yeah. So I hope that answers the question in regards to post processing. I will leave to Adrien for him to continue the rest.
Adrien, you're on mute, sorry.
Sorry, guys. Yeah, I mean, as soon as you have, post-processing, you know, one of the biggest challenge is to make sure that your process is known and you know what will be the different step after your printing, right? So, so as soon as you have a workflow which is master your design, you know what will happen into the building process. You know what will be the next step, like heat treatment can be one, but also milling or EDM or whatever. This is a challenge that we have seen since the last 10 years, and having, you know, a workflow which is clearly, I would say, identified will help also to the user to get, I would say, to be more comfortable about the full workflow in order to achieve the final parts, which will require a certain accuracy in terms of positioning, in terms of profile accuracy. So in order to achieve that, you need to have really your manufacturing process clearly identified, clearly mastered, I would say. Yeah.
Okay, thanks. Next question is more about the cooling channels. Maybe Simon and Mr. Zor can also input on this particular area. Okay, what's the geometry that is used for the cooling channel, circular or teardrops, or like the channel dimension? And also, because on the software side, I saw the NYP did some work with Sunningdale Tech as well as NAMIC on the simulation, etc., the design. Is there any thermal warpage simulation in that software as well? And how do you going to predict or designing of the cooling channels?
Yeah, can I answer first?
Yeah, sure.
Right. Yeah, the geometry varies depend on the features, right? Certain geometry, if they are large space, we will use a circular channel, but still the limitation of printing. For powder bed machines, the maximum channel diameter is about 7 millimeter. So if larger than that, we need to have kind of like slender type of channels.
Also,
right? Yeah. And teardrop shape is not so common for this conformal cooling, but certain area may need to use teardrop shapes, right? The smallest channel dimension we have printed up to as small as about 1 millimeter for certain very small features, right? During the printing, no much issue as long as you have kind of able to clear the powder in the channel after you have printed. So our SMEs or our local industries, they are more preferred on single channels than multiple channels. So I can understand that because for multiple channels, even though we have cleared the channels and also simulated, they are quite effective. And if they are kind of blockage in the injection molding, it's hard to detect. Right? So, but in Europe, especially in Germany, it's very common since more than 10 years ago. And we are trained how to design the multiple channels. So for single channel, the heat, although the cooling channel, conformal coolings are effective, but once you have twist and turn the channels, there will be longer path, right? So the heat can build up along the way, right? So that is another thing we need to be taken note of, and then take care of it as well, right? And for our simulation software, it's very fast solution or quick solution, not up to the accuracy of the kind of professional software. right? So the quick solution is the need for, based on our experience, where certain projects, we need to spend 4 or 5 days just for simulation and also optimizing the cooling design, right? With a lot of iterations. So if we, for example, change the path of the cooling channel with conventional, I mean the professional software, we may have to simulate overnight again, right? So after one change, right? So that really takes time. So we just want the indication for the designer, the kind of hotspot possibilities, right? So the developed software accuracy may not be like 80-90%, maybe about 50-60%, right? So, but it gives the first solution an indication of kind of a hotspot area or concern areas. Then the designer can interactively change the cooling channel designs. That shorten a lot of development and optimization of conformal cooling channels. Thank you.
Okay. Any points Simon would like to add? Okay, maybe.
Yeah, I think Shaw has answered quite comprehensively. Yes.
Okay. Okay. So I think one of the common things that a lot of people is asking is how does Simon your end? How do you clear the conformal cooling? I mean the channels, etc.
First of all, it's not good to have the cooling channel being too small, because from molding practicality, one of the concerns is that you do not want your cooling channel to get choked, because if it's too small, it typically will create problems down the road as well. And so we generally will make sure that the cooling channel is sizable enough to have no choking or choking problem. That's one of the very important thing. The other, so as far as the cooling channel is concerned, I know there's also a question about the flow rate, that heat transfer, and that kind of thing. So yeah, these are very important consideration. Those are very good questions as well. So the diameter should not be too big, too small. When it's big, when it can be too big, can be also a problem, because then there's not enough support. So the design of the cooling channel itself is also something that you need to look at. Okay.
Okay. In light of time, for those attendees that wants to have their question answered, please list down with your name, so we will also share with the panelists to get back, and then we'll get back to you. So we'll try to address a couple more questions, about 2 more questions, and then we can close the thing. So maybe for Hui Qi's side, is there any details on phase 3 and phase 4 of the grant, and if there's any fundings available?
Yeah, for phase 3 and phase 4, if you look at the chart just now, phase 3 is more on R&D and production design. So this can potentially be supported through our NAMIC grant. Yeah, we have to engage the company, and it will be evaluated on case-by-case basis. And then for phase 4, on scale up and adoption wise, this involves training of manpower and maybe investing more resources for your company. This one we will co-engage with ESG on to tap on their current EDG grant. So yeah, we need to look at the company outlook on how are they going to scale up this, and yeah, we will need to engage based on individual needs. But there's no particular grant call for phase 3 and phase 4. So if you have any need, you can email me directly, and then we will look at it and craft something that can tap on our current resources.
Okay, thanks. Maybe the last question I would like to ask Mr. Zhou. because you are training the next generations of engineers from NYP. Could you give us a bit more color of the skill set that the new generation of engineers that will be graduating? Would they have already hands-on experience in the 3D printing technology hardware itself, or mainly in the designing perspective? You know, give us a bit of insight. So a lot of the companies here, if they to adopt 3D printing as part of their business or part of their processes, manpower becomes or new engineers also will become one of the key challenges. I mean, they have to find the right engineers to come in as well.
Right. The new generation of engineers we are training, they are more digital, they are smarter, and also they can learn new advanced manufacturing technologies in a short time, and they can apply, right? So they are much better in quality. So we also train them a wide range of precision engineering background, both hands-on and also including design and simulations, right? For additive manufacturing in our diploma level, it is like one of the module for precision engineering and aerospace engineering, and I'm developing one for mechatronics engineering. So they will study as either core module or elective module, and where they also have hands-on using 3D printers and exposure to industry applications. And where they learn is mostly on final year projects, where they have 6 months, 3 months industry and 3 months in-house. And through the project, they will together with the industry partners and with the staff or the lecturers, they carry out the industry testbed solutions. And from there, they pick up their skills, right? But as in general, they have a basic knowledge of 3D printing or additive manufacturing. And only when they are employed or join to the AM sectors, then they can come back for our specialist diplomas and also the customized programs, right? For example, we also have like customized training for various industry like HP. We are trained about 200 engineers in past about 3 years, right? So these are also kind of skills training for existing employee as well as new recruits as well.
Okay, thanks. For the rest of the questions, we will get back. We will ask the panelists to input, and we'll get back to you individually if you have listed your name. Back to you, Royce. Thanks, Mr. Zoy, Adrien, and Simon, and Hui Qi. Thank you.
Thank you, Sean.
Thank you.
Thank you, everyone.
Thank you, everyone.
Okay, we have come to the end of the sessions. Thank you, everyone, for joining us today. It was a very fruitful and enriching sessions with all our speakers. If any one of you has any questions, we have a couple of contact information for you. With regards to the ESG-NAMIC Open Grant Call programs, you may contact Hui Qi via the email on the screen. And for any other general inquiries, do reach out to NAMIC or SPETA. And also don't forget to check our event page, as we still have plenty of events listed up for the years. Once again, thank you everyone for your time. Take care and stay safe. Bye.